Hi guys and gals, this is Henrik Palmgren. RedEyesCreations.com is our website, and you are listening to Red Eyes Radio, an independent internet radio program based out of the land of the Goths in the heart of Scandinavia. Nice to speak to you again. I hope you had a good week so far. Today we are going to talk about evidences of space weather-induced natural disasters with Dr. Kongpop U-Yen. He obtained his PhD degree in electric engineering from Georgia Institute of Technology, and as an electric universe enthusiast, he has conducted independent research on topics related to space weather and solar activities predictions. Welcome, Kongpop U-Yen. Thank you so much for coming on with us. Great to talk with you today. Everything good on your end?
Oh, yes. Thank you for interested in our conversation with me. I'm glad to be in this radio show.
Definitely. I mean, this is very interesting. I mean, I've been interested in the electric universe for a long time, and I think the work of Dave Talbot, Wallace Thornhill, and all the good guys there, Donald Scott and Rens van der Sluis, and a lot of the guys that's going to be on the conference as well is something that's just been really fascinating for a long time. And it's interesting to see that more and more people are coming aboard. Maybe you would want to tell us a little bit about how you got into the electric universe theory, if you will, before we get started and talk a little bit more about your work.
Yes. What motivates me in getting to electric universe theory is that I've been observing natural disaster and some earth changes events for several years now, and it's been started sometime in 2008, where I have a lot of information about earth changes and everything like that, and it seems like several people around the world have been predicting many things that's going to happen to Earth and our planets and solar system. And I was curious whether this stuff actually true? And since there are predictions like that, how can I tell if anything is actually true or is real? So I started doing my own investigation on this topic, and pretty much want to know if I would be able to forecast this stuff and in advance, in time. So people have been talking about things outside the Earth, about the sun and the climate change and other things. So the way to find out is just to do a pure observation of what's out there. We look at solar activity as well as earth change and see how they correlate, just the way it is, without having to dictate anything, or just looking at what the literature told us. Just look at the way it is. Not just only auroras or just electrical grid problems,
right,
or some radiation issues.
Yeah,
we just look at everything, and from there we try to find some relationship, and then from there we're trying to find some some theory that could explain such connections. So I start my scientific research that way. So I have a background in electrical engineer, but actually at the time when I start doing that research, I don't even aware that any electrical characteristic of space or Earth at that time at all.
This was not something you were familiar with. It wasn't within the curricula of what you studied, correct?
Yes, it's not in what I study at all. But even though I have a degrees in electrical engineer, I never expect anything of such connection with space.
Why do you think that is? Why are this not topics that are connected between electrical studies and just general space and what we've learned from physical assessments of reality, pretty much? Why are those not connected, do you think?
At the time, because it's just never been taught in school, and no one ever told me about electrical phenomenon in space.
Right.
So I just start with the guesswork, start with something that I can find in literature, and mostly try to explain the connection in terms of thermodynamics, or just heat and light, and pretty much something not electrically related at all most of the time.
Right.
And I sometimes find it not to make much sense, mainly because there's a lot of things in the world that happen so sudden without much warning, and and many of the theories seems to be trying to explain things in more gradual way. Um, uh, I can just give some example. For example, like
Yeah.
how the cloud become the cloud, and then the cloud keep accumulating and fall down as rain. I have been taught when I was young that it's like light just hitting um, you know the sea or the water, and then there's some evaporation occur
Yeah.
and become condensed and then fall down as rain. That process just takes so much time, and and it typically in reality, many things just happen all of a sudden. For example, that 2 years ago in 2011, there was a big flood in Thailand, and people over there have observed a huge amount of rain fall down from sky in 3 hours, and many scientists there have calculated amount of water that actually fall down from sky. It's just billion cubic meters or something
Wow.
like that.
Yeah, I remember that. 2011, there was a Thailand flood. It was just incredible. It wasn't. I mean, it was kind of compared to Katrina, really, in 2005, I
Oh
guess.
yes, it just a huge amount of water poured down from the sky in short amount of time. And if you can imagine that, if a classical theory where you have to wait for something to evaporate and accumulate into the sky, then you pretty much have a really good early warning already. But in reality, it just happened really fast. Same thing for tornado. Typically, they don't have a lot of warning, um, as well as earthquake or sometimes even volcanic eruption.
Yeah.
Many things just happen all of a sudden. It's really fast, and just using conventional theory, it just sometimes it just really hard to convince me if that's the case. That I can explain it. Um, so, so, so once I have been collecting a lot of information like this, and I have just start to find out that there's something is wrong, or not even wrong, or just some kind of misperception. It's just not quite the right view of what's going on
Right.
in the nature.
Yeah.
So, so I try to search for an alternative answer. So I came across Electric Universe. Just browsing through the websites and just find out, you know, that that they typically post like videos um, of the explanation of how things works in the universe, and how electricity have um, um, a very major role of what's going on out there
Yeah.
in space, and it's just make me fascinated. And I go down, I go back in time and look at the work from the Norwegian Christian Berkland
Yeah.
and other people, and I found that they have been doing a lot of experiments about plasma that it seems to fit really well with what's going on. at the sun as well as on Earth. Um, and from there, I have been doing a lot of study about other things and just ask question if there's some kind of electrical um, uh, connection with all these climates, um, as well as other, like Bertrand currents phenomenon that happen around, how the energy transferred to the Earth. So, so that's become, so that kind of helps solve many of the problems that I have in my mind. So these are the things that I'm going to be talking about at the conference.
Right.
Yes.
So is this anything that you study at the Georgia Institute of Technology at all, or is this just kind of your pastime, your interest?
Oh, this is my pastime. I mean, yeah, my interest after I finished my degree, and it just happened from nowhere, meaning that I'm not even expect the stuff that I've been learned in school be used to explain this thing.
Right. This is
So it come later time after I've been observed what's going on in the nature for a while, and it just fits pretty well.
Absolutely. Now, so yeah, let's talk about some of these examples then. I mean, space weather induced natural disasters. It's just a really interesting topic, and we could even begin with the flood then in Thailand. What in the electric universe world, if you will, then how do we explain some of these monumental amounts of water just precipitating during such a short time, and how is this driven by space weather?
Okay, I think we should have two different topics here. First is that a little understanding about how space can induce natural disaster first, right?
Yeah.
And the second is how the rain can how the water can be accumulated so fast and fall down from the sky so fast.
Yeah.
So let's split into two topics. So we talk about a big picture first, which is a space-induced natural disaster. So I would like to begin with a really simple concept first, that we, human being, we observe ourselves first. Human beings or any living organism, we have to accept that, we cannot be able to sustain by ourselves, right?
Yeah.
Living organism, if we can define it, living organism should have something, that energizes us. So we have heat inside us. So we kind of have a higher temperature than the environment. We also relies on air that we breathe in. We require food, so energy. We consume it, so it's got burns, and that's how we get energy internally inside us, right? So we cannot just live by ourselves without relying on anything else.
I know people are trying, but that doesn't work out too well in the long run.
Okay.
No, I'm
so
just
if
joking.
you don't eat, can you survive?
No, that's what I'm saying. I'm joking a little bit about that. I'm talking about some of the new age ideas out there. But nonetheless, let's not go off topic here.
So let's just go along with this a little bit.
Yes.
Human also have cycle, right? We need to sleep, and also, we have a cycle of activities. And our activities typically, have some kind of interaction with environments all the time, right? So if we use this kind of concept back to Earth, and we see this Earth is a living organism, just like human. Earth itself is hot inside; it has energy inside. It also have air surrounding it. It also have cycle, season. So it's a living organism, pretty much. So how can some living organism all of a sudden have something occur? Of course, it has to have a trigger, and those trigger can be both internally and externally. So just like human, that we interact with environments. And if you move forward a little bit more, you know that let's say if there's a wind blowing to us, let's say we are at this temperature and there's a cold wind blowing to us real fast, and we could shake pretty much. We feel the wind and we shake, right?
Yeah.
Or sudden. And how do we know? The wind is invisible to us, right? We don't know if the wind's blowing, but we only know when it's actually touch our skin.
Right.
But how do we know as the wind blows? Is like, okay, we can see some leaf moving around. The leaf itself is not the wind, right? It's a separate thing.
Yeah.
And also we respond to the wind. So same thing for the earth. If you come back to the earth, there's wind blowing at earth all the time, and this you can say is a solar wind, and solar wind is not uniform either. So they're just not something that is static or has constant velocity. So it change over time,
Yeah.
and dependent on the solar activity. So, and when the winds blow, if we live in the past, we don't have any things to monitor what's going on. So we just must be thinking something just occur on the Earth by sun by some coincidence. But today we have all the satellites that detects all kind of energy particles and that coming in. So that's kind of representing, those leaves that we just detecting. And vacuum is just a medium that carrying the energy. So in this case, you know that if something blowing in or some sudden change, of course, sudden change will happen to Earth as well. So this is a very simple concept of how space weather can induce something on Earth. Okay, now the next topic is, okay, what causing the wind? So we know that the sun, which is one of the biggest objects in the solar system, we can observe the sun as it's changing in activities. And those activities, whatever is changing over there, and then we observe back to ourselves, which is on Earth, what's going on. So if you see the picture like this, it's become clear that, okay, if something's going on at the sun or somewhere in space, some kind of fluctuations that's going on, of course, Earth will respond.
Yeah.
It's very simple concept.
Yeah.
So this is how space weather can induce natural disaster. So come back to a little bit more scientific language. So the way we observed space weather currently, we look at charged particles, change in charged particles, solar wind speed, as well as magnetic field, Earth's magnetic field. These are the things that what scientists commonly use for monitoring change or fluctuations. Another one that we should be consider and is very, very important that they have not talked about much in the past, but they have been start talking about it more, is electric field. As you know that everything works in dualities, like in electricities, there can never be only magnetic field, right?
Right.
Like in electrical circuits, almost every electrical circuits, it's always have inductor and capacitor and a resistor.
Mm-hmm.
You can never have only inductor. There's only really hard to find anything in nature that only works with only inductor and a resistor. So in realities, we have all. So what we should observe more in nature is electric field, potential difference, and the fluctuation of electric field that's going on around the Earth. And we can observe this really well through Van Allen radiation belts, which now we know that we have at least two of them, two belts, and there's the third one that's just showing up from the satellites.
You're talking about the Van Allen belt, and which one? Do you know what the other ones are called?
The third one, we just been discovered using Van Allen radiation probe. I'm not sure what it's called yet, but
they don't have a name for it yet, huh?
Not quite sure. But it's this phenomenon. I think Thornhill has described it as a phenomenon of plasma double layer phenomenons.
Right.
So, okay, let's talk about plasma a little bit. The plasma double layer is a form that is a phenomenon where charge was split into layers, and somehow it's a type where it can store energy, just like capacitor. And if you look at Earth in the same way, Earths also have layers of potential. So on Earth itself, there's about the net charge of about 1 million coulombs on the surface. And between surface and stratosphere, or a place far above, there's also a potential difference of about 300,000 volts, and it fluctuates all the time. So the Earth itself also separated by, so let's say an ionosphere, and between ionosphere and Earth there's a insulation. So it's a big capacitor. Earth itself is a big storage. It's a big storage of energy. So, and this energy is not static. It's like a capacitor that has a plate moving along its longitude all the time. If you think about it that way.
Right. Yeah.
So if those plates, you think Earth is a big battery, and the battery is moving, the positive and negative plate is moving back and forth all the time. So of course there's going to be something going on in terms of charge that's moving on that plate, the positive plate and the negative plate, and vice versa.
Yeah.
So by just manipulating only the electric field alone, you can have some certain phenomena, which one is the force, the movement of the particles that can accelerate according to electric field. For example, water, H2O. The H2O, the way it's arranged is you have one oxygen and two oxygen on the other side. So the molecule itself has a dipole characteristic. So this dipole also responds to electric field. So you can have water that moving can accelerate and moving toward the atmosphere really fast if you have something that abruptly change the electric field. The Earth.
Right.
Okay. So if from the conversation you can see that I hardly talk about any magnetic field at all.
Right.
So these are the things that a little bit off from what we publicly have been educated about Earth, about magnetic field.
Indeed. Oh yeah.
So magnetic field also play important roles, which mainstream science has been studied quite intensively, mostly around the polar region, where we have auroras, northern lights, around the pole area.
Yeah.
So that thing has been well studied. So that's why I'm study electric field part more.
Right.
So that we just open up a new possibility of understanding Earth a little in another perspective. So So what can cause electric field fluctuations? So you can see that it just not all of a sudden can fluctuate, right? So there are many ways to produce a fluctuation in magnetic field. One, of course, is internally fluctuated by itself. That's one. But again, if you compare this with human, we just all of a sudden just shaking up by ourselves.
Yeah,
Right?
something has to drive that. You can't just
Right. Something
spontaneously
has to
occur.
drive it.
Yeah.
Yes, exactly. So that's why we look for clue outside the Earth, see if there's a fluctuation of electric field or magnetic field that's going on. If recently scientists has been study a lot about Van Allen radiation belts, and we know we have discovered there's a lot. It's a giant electric field that's actually energized Van Allen radiation belt from the outside. And of course, electric field or capacitor, it works as layers. It's layers of layers and of layers from externally to underground. So, for example, if you the first band radiation belt is mostly consists of positive and negative charges. If you move towards outer layer of band radiation belt, it's mostly negative charges. If you move towards now, if you go back to the surface of the Earth, in average is negative charges. So it's a charge alternations. Positive, negative, positive, negative, positive, negative.
Mm-hmm.
So by having charge separation there, you have a capacitor already. And you have charge separation, you have electric field. And when you have electric field, you can have stress. If those stress is in the rocks, in the plate, of course, that could have stress occur. If there's a huge amount of charge just moving along the stress of those rocks, you can have earthquakes.
Right.
So when the charge accumulate up to certain point, there's a threshold. So you have a current discharge occur between two dielectrics, between two conductors, where there's a dielectric where it stores energy. So you can have earthquakes occur underground, which is a sudden phenomenon as well. And scientists has talked about this. It's described it as some kind of displacement current that occur when the earthquake occur. So you have heating effects, you have sudden change in electric field, and we also have before earthquake occur, we also have compression of ionosphere. So which is a change in electric field.
And is that anything that has produced what they call the earthquake lights? That there is a
Yes.
electrical phenomena? Yeah.
Yes, earthquake lights. Lights also can be produced by electricity, right?
Yeah.
Yes. So yes, so they're all connected, and we also using this theory, we actually have clue of broadcasting earthquake as well.
Well, that's pretty interesting. That would get us a long way. How long before? I don't mean to cut off the topic here too much, but it's interesting just to ask about this. How long before do you think we usually get warnings about this? Is it just simply, all right, let's monitor solar activity and CMEs and everything else, and that could potentially just give a clue as to where and when in terms of earthquakes?
When it's easier to answer, but where is a little harder.
Yeah.
When if everything occur with the cause, and the cause has to have a right conditioning on Earth in order to occur. But we know if they're the right factor happens to be at the right time, then earthquake will occur.
Yeah.
For example, like today, if you follow the earthquake news, there's a significant earthquake happened at the south of Kermadec Island near New Zealand,
Mm-hmm.
about 6.5 Richter scale, occur around 9 universal time. Um, if you follow the solar activity news, you find out that there's a significant events occur on January 30 and 31st, and that's a warning that has been published by NASA and NOAA, and has been calculating the time that the energy will arrive here around that time, which is on today, pretty much.
Right. We're recording this on February 2nd, by the way, for those who want to check those news and the correlation there with the earthquake in New Zealand. So is it? I mean, obviously we had a couple of M-class flares recently. That's the main
Yes.
drive here. Yeah.
Yeah. People look at solar activity mostly have flares as an indicator of solar activity. Um, in realities, there are many different indicators of sudden events at the sun. So we just call it a sudden phenomenon at the sun. And solar flare is one of the indicator. We have coronal mass ejection as another indicator. We also have abrupt change of sunspots. We can also look at the coronal hole, which is some black area in the chronosphere, photosphere of the sun, chronosphere. So there's many ways that we can look at the sun in terms of finding an impulse signal. And can I move this back to a little bit? So,
yeah, sure, definitely.
Okay. So for audience to understand it's easier, look at this as we can visualize the sun as a power generator.
Yeah.
Somewhere far away, and Earth is a light bulb. And between the power plant and Earth, and the light bulb, there's a wire coming from the power plant to the light bulb. And energy that comes through the wire is invisible. We can't see it, but we can probe it. We can look at the magnetic field that generate from that current that come from the wire. And of course, if there's an impulse at the power plant, of course, the light will be flickering. It's a very simple concept like that. So we are looking at impulse at the power plants, which is the sun, as one of the source. An impulse is something that happened rapid over a short period of time, but not a long period. I just want to emphasize on only short-term changes, not a 11-year cycle, but a short terms in like day-to-day basis.
Right. There are massive cycles. Some we kind of just are discovering and hinting at, and minimums and maximums and everything else. So you're just talking about the short-term impulses that occur and how that more directly usually within 24 to 48 hours, I guess, that has an impact on the Earth in some way.
Yes. So if you observe an impulse at the sun and then look back at Earth, see what's going on at Earth, you can see the impulse on Earth. So the impulse doesn't have to be just a fluctuation of magnetic field, but we also refer impulse as some kind of could be an earthquake, could be storm formation, could be a sudden drops of rain pour down like a flash flood, could be volcanic eruptions, for example. So these are the things that we look at, and we can find some correlation, pretty kind of rough correlation right now in this part.
Is there any indication that gives us clues as to where the effect, if you will, of this energy discharge is going to occur? Because as you said, I mean, it could be it could be a number of things within our natural environment that accumulates this energy, and then you get an effect. Here there could be,
Yes.
yeah, earthquakes. We have flash floods. You have strong winds. There's a number of things. It's very difficult to pin that down. Correct?
Oh, yes. It's difficult in terms of location wise because if you think of the way I do research is I treat Earth as a human body, and when the wind blows, the body shakes, but which part of the body will shake is kind of another topic.
Yeah, indeed.
So, but we look at a significant events. For example, how to find what is significant and what is not. For example, I live in Virginia, United States. So an earthquake of 5 Richter scale in Virginia is significant, right?
Yep.
But if I live in Japan, earthquake of 5 Richter scale is not significant.
Right.
So we look at something that just happened, all of a sudden, and could be a potential, harmful to human, something like that.
Yeah.
So let's talk about. Sorry. Now I think we kind of quite clear on the global scale. Now we move to a topic of rain, right?
Yeah.
Okay. So the way it works in electrical phenomenon is that if you, let's say in winter time, you comb your hair, and the hair somehow just rise up, right? Through electrostatic phenomenon. So it has some kind of attraction. So by having electric field alone actually can cause levitation of an object. And this can be proven pretty easy using a lifter experiment, which is kind of aircraft, an aircraft that powered by electric field alone can levitate. So same thing for water and clouds. If you look at clouds, and water itself is polarized, so you have cloud levitates above the air, and the cloud itself and water that's in the cloud is much heavier than air. So the only way that can make it rise and carry huge amount of water, like tons of water, could have to be some kind of electric phenomenon. And the way, if you observe the cloud a little more, you see that before it starts to rain, you hear cracking sound, and you see flash of lightning. And once you hear those kind of things, the rain starts falling down. So I can show in the experiments very easily that if you have something that levitates using electrical charge, if you have some charge which is in the opposite polarity and bring it close together, it become arc. You got an arc,
right?
The lightning. So once the energy got transferred and the charge become recombined and become neutralized, the force disappear. The force of levitation just go away, and it fall down. So that's why you can have some really sudden change, which could cause falling of rains in short amount of time. So how to do that? You just make the electric field change all of a sudden. And when you have a sudden change in electric field, you can have charge moving and start to recombine, and really all of a sudden, and it creates an avalanche effects, which just all of a sudden it just fall down.
Flash floods and
yes.
Yeah. I mean, it's pretty incredible to me when we've been talking about sun activity and correlation to very quick, weather pattern changes and even Earth changes, as you said, for a long time. But
Yes.
it doesn't seem to be kind of acknowledged in the mainstream for some reason. I mean, despite the massive energy output of the sun, it's still, I mean, it's beginning to get there a little bit more and more, but it's still kind of, it's been a slow, long time for this to catch on for some reason. It's kind of weird,
Oh
isn't it?
yes. Many people may argue that energy that coming from the sun is just not sufficient to produce some big change here. But if you reflect the same, if you reflect yourself as Earth, when the wind blows to you and you shake, is that energy that shaking come from the wind? It's not. It's actually from ourselves, which is Earth.
Right.
But we just need the right trigger to produce the right effects. So in this case, lightnings and energy that got accumulates is actually come inside from inside the Earth, but actually relies on energy from the outside that's building up those energy, and then all of a sudden you have a trigger that could cause avalanche effects that will occur, and those trigger could be external. So that's the point.
Indeed. Now, is
Yep.
there any indication as to, I mean, are there, as we know, maximum events that have occurred in terms of input of energy? I mean, as you said, you haven't so far looked at maybe the long term of output of the sun, but we know that it has massively different, cycles on energy output. We've, allegedly we're going into a somewhat of a solar minimum right now. The
Yes.
sunspot count is very low. So are
Mm-hmm.
we overall going to expect, I mean, look at when was there was a bunch of hurricanes. Was it in 2009, 10, and 11, I believe? And then after that point, it's pretty much diminished.
Yes.
And we haven't seen any tropical depressions form even. Oh, they have formed, but they haven't caught on and, accumulated the energy that they need to. So can we compare it in this way and just say that, all right, we have a solar minimum, therefore the likelihood of these disastrous, events are lower, smaller?
If you're talking about a long-term trend, would be probably yes. But in terms of short-term, we still will have tropical depression. We still have tornadoes, but the intensity of it is depending on the energy that we receive at that time. So, for example, like last year, we have a really strong typhoon in Philippines. Um, it's still very strong, right?
Yeah. Oh yeah.
That's at solar maximum, even though this solar cycle is one of the lowest, in terms of energy in 100 years.
Yeah.
We still have super typhoon, very big typhoon in Philippines, and but if you look at that time when the typhoon occur, before that, about 2 to 3 days, you see a big solar activity at the sun, and it's a big impulse of the sun that occur. And then if you calculate the time that energy will arrive here, you know that okay, you're gonna have something going on for sure.
Yeah. Yeah.
So and then all of a sudden you see tropical depression start to form and become super typhoon in about 2 days,
Wow. So
two to three.
it could have been much worse as well if there was even more output from the sun.
Oh yes, it depends on the how sudden the event occur, how big the event is that we observe at the sun, and there's also other factor too. I'm open to all kinds of fluctuation in space, not only from the sun, but could be from other source too.
Exactly. And how do you how could we explain that considering the distances here? That's in this case you said vacuum actually works as a capacitor.
Vacuum is a medium.
A medium, sorry, yeah, yeah. So it doesn't matter how long the distances are. If something is put out an energy or charged particles or whatever, eventually that's something that's going to reach us if it's in the right direction, correct?
Direction is one, and the depending on, it's not only depend on external, also depend on the preconditioning on Earth as well. For example, if we are in the time where it's seasonal related to the Earth as well. For example, if you're in the raining season, let's say in tropical zone, of course the tendency of having a intense storm is higher than when during winter time, for example. So there's many factor. Also for external factor like the sun, we also look at direction of the energy coming from the sun. What I found from just looking the way it is that it doesn't have to be directly hitting Earth to have an effect. It's only need to have a big impulse. And as long as there's something changing rapidly that is visible from our side. For example, I would say like big sunspot or huge sunspot, all the sun just form really fast. The main direction doesn't have to be toward the Earth. You will see something. So this is something that I have discovered just doing the observation.
What kind of experiments have you done to replicate some of this? How do you do that? Maybe we can talk about that a little bit.
Yes, mostly actually it's related to electric field, not magnetic field much.
Right.
So we can look at Tesla wireless power transmission. That's one thing that you can do experiment with. In Tesla wireless transmission, you have a sphere, two sphere, and it's connected to one wire. And if these two nodes are in resonance, they are locked in resonance. It's respond really close to a static. It's like a static field on one side and a static field on the other side. If some fluctuation occur on one of the source or destination will change as well as if there's some kind of a hand movement or something that a wind blowing on the other side, you see fluctuations.
So it has to be in maybe not in a vacuum, but it have to be in really still, or I don't know how to say, quiet conditions, or
it can be in vacuum. It's going to be hard to visualize here on radio, but the easiest analogy I would say is like the power plants and the light bulb.
But let me ask you this, because we've seen some of those images when Tesla is sitting on a chair or is standing up and he's holding a light bulb that actually lights up. Mm-hmm. Is that the visual we can have here?
Oh, yes. I mean, and it's really just like that. And if you have a sudden discharge, Tesla also experienced some kind of rise in his hair or something on his skin as well.
Yeah.
So it's those kind of things that we are talking about.
Do you know if that is that bad for your health to have those fields, passing through you and being around you? Do you know?
Well, I have to rely on other people's research on this.
Yeah.
From my own experience, if we observe this very often, let's say for today, how do you feel compared to 2 days ago in terms of your mental sanity, and you can look at that, compare that to solar activity level. Some people may observe some change in their emotion and things like that. And from research, people have found that, from medical research, they found that people typically have there's a higher risk of heart attack occur when there's high solar activity.
Ah.
So that's out there on the internet. We can search on that correlation there, but I don't know for sure.
Well, that's pretty interesting, though. Nonetheless, I mean, I've heard that too. I got sent another paper a while back that actually monitored, and again, this was a long-term cycle, but but they actually monitored war and correlation with solar activity, which seems to correspond, which was pretty interesting, meaning that there is a tendency for more aggression, I guess, when there is more energy
Yes.
input as well, which is pretty interesting.
Yes, I observed that too.
Huh, that's interesting. So how do you see that this is going to develop in the future, do you think, in our understanding of this and correlation between I mean, we have a field called space weather now, more or less. I mean, all the different space agencies are part of monitoring this and seeing the effects and everything. But I suspect that we're going to learn a tremendous more amount of material on this in the next 10, 20 years. What do you think?
Oh, yes, definitely. The more we now have huge amount of information from the satellites that have been gathering and has been launching to space, and the more we observe, the more we understand about how things work, and of course, it's the field have to keep evolving, according to new information that comes to us, and of course, and the more people um, test the theory of electrical theories, the more people observe and found the correlations by their own, the more information will keep spreading and spreading, and people will start to find out how all these things are connected.
Yeah, definitely. Do you think the electric universe is something that's going to catch on more in academic circles?
Hopefully, yes. As well as many of the research that Tesla have been doing can help explain this thing as well.
Yeah. Interesting. So, what are some of the other things that we haven't mentioned here? That well, you both the research that you do, of course, as well, but some of the things that you're going to talk more about.
Oh, so this is all you. The more I can talk about would be something associated with earthquake. Um, um, we, but other than that, probably I would say it's kind of beyond what I can claim because it's just something to study more.
Well, exactly. And how are you going to proceed now in your work? Or are you just going to continue to correlate and do experiments and see effects on weather? Is there any other big area that you're looking into next here?
Um, this just to be confined to this topic is I like to do more of a public outreach on help people understand how this thing works. I mean how nature behave electrically, and try to kind of encourage them to see for themselves. See the real experiment. Observing the real what actually happened to themselves um, when there's something happen in space.
Right.
So it's more of people prove this stuff by themselves and see if it's actually something useful for them. Then we just move on from there.
Absolutely.
So
I mean, and the big thing here as well that you kind of briefly mentioned is that this could basically help to save people's lives as well. The more we can learn about this and become aware of specifically, then the question which is difficult is the where question specifically. But nonetheless, if people are generally aware of it, if general alerts go out, I think people would be more kind of aware of their surrounding. They would be more kind of in tune with what's really going on. So this is a big field that could develop. And again, I don't understand then why not more money is going into this, considering the ramifications. I mean, if you look at compared to other industries where saving lives is concerned, there's a lot of money in those fields. You know what I mean?
well, we make something uncertain become more certain. So
Exactly.
it's a good thing. Another thing that I would like people to be aware of is that um, about how Earth interact with other celestial objects, and these are the topic which a lot of controversial right now, like how other planets, is affecting other planets. And yeah, I think this would be a separate topic, and it will have to be talked at other time, I guess, because it's going to be quite long as well.
All right. Well, that's interesting though, because I heard that too, and that even the interplay between different planets actually it can help to balance input energy to the Earth and help to kind of offset it and stuff like that. So it's very much dependent on the combination of planets for the kind of either a big event to occur or for something to be diminished. That's what I've heard about that anyway.
Yes, we look at in my perspective, I treat planet as circuits. It's a big circuits in solar system, and 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 each one has its own kind of a periodic cycle, and everything that has cycle seems to have some kind of a resonance. It's a resonant circuit, and that could goes in that's go beyond, not quite beyond, but could help extend electric universe theory into something more of a larger scale, something that relate to what Tesla has been working on, was working on in the past, and I would say it. Currently, I don't have a full understanding of that part yet.
Right, right. Yeah, there's more study to do that. Well, let me ask you another thing here before we begin to round things up then for this time. Do you think that we'll see another Carrington type event anytime soon on this planet? And if so, obviously the effects would be disastrous. But again, we're in a solar minimum allegedly right now in a way. But
Yes.
if we go approach another maximum and things go real bad, what do you think will occur?
There's some research from a few scientists related to Carrington events and the cycle of solar activity. What they have found is that during the solar cycle, where the energy is not background energy is small, like this one, there's a big chance of having a big solar event occur. But other than that, I'm not quite sure
Well,
this time.
we'll just have to see what happens, I guess.
Yes, you have to see what happened. And again, just would like to public to be aware about this, that uh, solar activities has more impact to Earth than just auras and global communications. If we open up our understanding to climates and how the tectonic activities behave, we know that there's a connection between external world and our world, that that you know that could help us, uh, kind of create a better warning system and save life.
Well, exactly. Do you have any comments on all the discussion that's been going on in the last? Well, it's been going on for a long time, since the 70s at least, but more recently, climate change and the correlation to sun activity. Are you? I mean, a lot of people are beginning to look at the sun as being the primarily driver, and they see that that influences things way more than human beings. Any comment on that?
Yes, the sun. Without the sun, we probably don't have any life here.
No, no, we don't. That's it.
So yes, it's a main driver. If one could argue that you can just remove the sun and we just have human activity alone, I don't think you're gonna have climate change.
Oh, absolutely not. We would have no life here, not at all. So,
So yeah, it's very obvious.
yeah.
And there's some other researchers who have talked about some external energy from outside solar system as well that could have big impact on the whole solar system itself. Um, the, Many people have talked about climate change on Mars and other planets. So those are the same kind of thing, the same scheme that I've been talking about. So it connects with other research work. as well.
Well, indeed, much more study of this on these topics, of course, is needed. But nonetheless, I'm glad to hear that you're putting an interest into the electric universe and looking into it, and there's much more to discover that. But for this time, then we want to thank you for your time, Kongpop. Really appreciate you talking with us on this interesting topic. If there's anything else you'd like to leave us with, please do that. And we don't have directly any, I guess, website for this time to give out personally from your end, but we do want to mention the thunderbolts.info and go to the Electric Universe 2014 conference page there as well, and you can read more about Kongpop and all the other speakers that's going to be there this year as well in March in Albuquerque, and we're going to be there also from Red Eye, so it's going to be really interesting to meet all of you guys there and everything else. But yeah, please go ahead if there's anything else you want to mention. Go ahead.
Okay. To study science, we actually, in order to gain real understanding of what's out there, we have to see the real thing, and we have to observe it through our own experience. Understand science is not just reading in textbook and just accept what's in the textbook without actually prove it to yourself. And sometimes by seeing the real thing, actually, it's just more than what you can describe. So I will encourage people to observe this phenomenon by yourself and make your own judgment. And I will provide some experimental confirmations at the conference. So for everyone who will be attending Electric Universe conference, so will hopefully benefits anyone who is interested in this field. So
absolutely, well said. Well, it's a good point there. Don't get stuck in the theoretics too much, but actually look at some of the observable, well, in this case, empirical data and tests that people can do on themselves there. So well said. Well, thank you, Kongpop. Really appreciate this. We'll round things up for this time, Dan. Thank you again for coming on.
Oh, thank you very much.
And that wraps up our program for today. We have, of course, much more coming in the next few weeks. Up next on Monday, Karen Hudes from the World Bank. Then we have Barbara Peterson from Farm Wars. David Icke and Daniel Estlin is up after that. Many more, of course, is upcoming. You have our full guest list in the radio archives. If you haven't already, check out our members archives at redicemembers.com. You can sign up for a subscription and download or stream any of our previous programs. We have well over 800 programs at this point, going back to 2006. A lot of material for you to dig into. All right, then. Well, we'll wrap up here. Thank you again for listening. We'll say thank you to the Red Ice team as well. Have a good day or evening, and we'll talk to you in just a few days. Take care.
This is Red Ice Radio for the Seeker.
Hi guys and gals, this is Henrik Palmgren. RedIceCreations.com is our website, and you are listening to Red Ice Radio, an independent internet radio program based out of the land of the Goths in the heart of Scandinavia. Nice to speak to you again. I hope you had a good week so far. Today we are going to talk about evidences of space weather-induced natural disasters with Dr. Kongpop U-Yen. He obtained his PhD degree in electric engineering from Georgia Institute of Technology, and as an electric universe enthusiast, he has conducted independent research on topics related to space weather and solar activities predictions. Welcome, Kongpop U-Yen. Thank you so much for coming on with us. Great to talk with you today. Everything good on your end?
Oh, yes. Thank you for interested in our conversation with me. I'm glad to be in this radio show.
Definitely. I mean, this is very interesting. I mean, I've been interested in the electric universe for a long time, and I think the work of Dave Talbot, Wallace Thornhill, and all the good guys there, Donald Scott and Rens van der Sluis, and a lot of the guys that's going to be on the conference as well is something that's just been really fascinating for a long time. And it's interesting to see that more and more people are coming aboard. Maybe you would want to tell us a little bit about how you got into the electric universe theory, if you will, before we get started and talk a little bit more about your work.
Yes. what motivates me in getting to electric universe theory is that I've been observing natural disaster and some earth changes events for several years now, and it's been started sometime in 2008, where I have a lot of information about earth changes and everything like that. It's like light just hitting, the sea or the water, and then there's some evaporation occur,
Yeah.
and become condensed, and then fall down as rain. That process just takes so much time, and it typically, in reality, many things just happen all of a sudden. For example, that 2 years ago in 2011, there was a big flood in Thailand, and people over there have observed a huge amount of rain fall down from the sky in 3 hours, and many scientists there have calculated amount of water that actually fall down from the sky. It's just billion cubic meters or something.
Wow.
Like that.
Yeah, I remember that. 2011, there was a Thailand flood. It was just incredible. It wasn't. I mean, it was kind of compared to Katrina, really, in 2005.
Oh,
I guess.
yes. It just a huge amount of water poured down from the sky in short amount of time. And if you can imagine that, if a classical theory where you have to wait for something to evaporate and accumulate into the sky, then you pretty much have a really good early warning already. But in reality, it just happened really fast. Same thing for tornado. Typically, they don't have a lot of warning, as well as earthquake, or sometimes even volcanic eruption.
Yeah.
Many things just happen all of a sudden. It's really fast, and just using conventional theory, sometimes it just really hard to convince me if that's the case. I can explain it. So once I have been collecting a lot of information like this, and I have just start to find out that there's something is wrong, or not even wrong, or just some kind of misperception. It's just not quite the right view of what's going on in the nature.
Yeah.
So I try to search for an alternative answer. So I came across Electric Universe. Just browsing through the websites, and just find out, that they typically post like videos of the explanation of how things works in the universe, and how electricity have a really a very major role of what's going on out there in space, and just make me fascinated. And I go back in time and look at the work from the Norwegian Christian Berkland.
Yeah.
And other people, and I found that they have been doing a lot of experiments about plasma that it seems to fit really well with what's going on at the sun, as well as on Earth. And from there, I have been doing a lot of study about other things, and just ask question if there's some kind of electrical connection with all these climates, as well as other, like Berkland currents phenomenon that happen around, how the energy transferred to the Earth. So that's become, so that kind of helps solve many of the problems that I have in my mind. So these are the things that I'm going to be talking about at the conference.
Right.
Yes.
So is this anything that you study at the Georgia Institute of Technology at all, or is this just kind of your pastime, your interest?
Oh, this is my pastime. I mean, my interest after I finished my degree, and it seems like several people around the world have been predicting, um, you know, many things that's going to happen to Earth and our planets and solar system. And I was curious whether are this stuff actually true, and since there are predictions like that, how can I tell if anything is actually true or is real? So I started doing my own investigation on this topic, and pretty much want to know if I would be able to forecast this stuff and in advance, in time. So people have been talking about things outside the Earth, about the sun and the climate change and other things. So the way to find out is just to do a pure observation of what's out there. We look at solar activity as well as Earth change and see how they correlate, just the way it is, without having to dictate anything, or just looking at what the literature told us. Just look at the way it is, not just only auroras or just electrical grid problems,
right,
or some radiation issues.
Yeah.
We just look at everything, and from there we try to find some relationship, and then from there I'm trying to find some some theory that could explain
right.
such connections. So I start my scientific research that way. So I have a background in electrical engineer, but actually at the time when I start doing that research, I don't even aware that any electrical characteristic of space or Earth at that time at all.
This was not something you were familiar with. It wasn't within the curricula of what you studied, correct?
Yes, it's not in what I study at all. But
right.
Even though I have a degrees in electrical engineer, I never expect anything of such connection with space.
Why do you think that is? Why are this not topics that are connected between electrical studies and just general space and what we've learned from physical assessments of reality, pretty much? Why are those not connected, do you think?
At the time, because it's just never been taught in school, and no one ever told me about electrical phenomenon in space.
Right.
So I just start with the guesswork, start with something that I can find in literature, and mostly try to explain the connection in terms of thermodynamics, or just heat and light, and pretty much something not electrically related at all most of the time.
Right.
And I sometimes find it not to make much sense, mainly because there's a lot of things in the world that happen so sudden without much warning, and many of the theories seems to be trying to explain things in more gradual way. I can just give some example. For example, like how the cloud become the cloud, and then the cloud keep accumulating and fall down as rain. I have been taught when I was young that